You are about to hear something that identifies the exact moment a purely natural space rock began acting like a calculated machine. For years, the scientific community insisted that Oumuamua's strange, non-gravitational acceleration was a unique, never-to-be-repeated mystery. Yet, as of May 2026, the data rolling in from NASA's JPL Horizons database regarding our newest interstellar visitor, 3I Atlas, has forced a highly elite group of astrophysicists to quietly reopen the exact same debate. This digital reconstruction reveals that the comet didn't just speed up under the sun's glare, it did so with a mathematical precision that defies natural randomness. Our journey into the calculus begins with the perihelion deviation. When 3I Atlas reached its closest approach to the Sun last October, interplanetary sensors tracking its orbit noticed a distinct drift. According to data finalized by the Minor Planet Center, the comet experienced a significant non-gravitational acceleration that peaked at roughly 89.3 times 10 to the -9th astronomical units per day squared. Mainstream consensus quickly attributed this push to standard cometary outgassing, assuming the sun's heat was vaporizing pockets of carbon dioxide ice. However, when researchers mapped the vector of that acceleration, the natural rocket effect explanation began to show deep structural fractures. A major scientific disruption occurred when dynamicists calculated where that extra speed was steering the 5-kilometer giant. A trajectory model known as Solution 44 revealed that the non-gravitational thrust acted as a highly precise course adjustment. A measurable recalculation showed that this specific acceleration perfectly maneuvered 3I Atlas toward Jupiter, guiding it to a minimum close approach distance of 53.6 million kilometers on March 16, 2026. What sent a shockwave through the planetary science community is that this distance is virtually identical to Jupiter's Hill radius, the exact geometric boundary where the gas giant's gravity overpowers the sun's. Tide. According to probability equations published by Harvard's Avi Loeb, the likelihood of a random interstellar rock utilizing natural outgassing to hit that exact orbital sweet spot is less than 0.004%. If the comet had been moving just a fraction of a meter per second slower or faster, it would have missed the boundary entirely. Instead, it coasted perfectly along the line where fuel requirements for orbital insertions are minimal. This has forced researchers to quietly investigate an uncomfortable question. Did 3I Atlas use the sun's energy to intentionally guide itself to the outer solar system's primary gravitational gateway? Every new simulation of this path introduces a fascinating realization. We are no longer debating a simple drift in space. Deeper implications suggest that while the object looks like a messy, active comet, the underlying mechanics hint at a highly structured system, what some describe as a stealth traveler. It may be using the chaotic veneer of venting carbon dioxide to mask a highly deliberate trajectory. As 3I Atlas officially crosses 1 billion kilometers from Earth this week, silently exiting our system via the constellation Gemini, we invite a calm appreciation for its mystery. The public press conferences have stopped, but behind closed doors, the math is still being checked. The universe has handed us a second interstellar anomaly, and it has proven that the line between a natural wonder and an artificial voyage is becoming beautifully, terrifyingly thin. On the 19th of August, 2025, the automated sky survey at the Pan-STARRS Observatory on Haleakala recorded a faint, non-periodic point of light moving against the background stars of the constellation Pegasus. By the time, the trajectory was cross-referenced with data from the Vera C. Rubin Observatory 3 weeks later. The object, designated 3I Atlas, displayed a persistent deviation from a purely gravitational path that could not be accounted for by the outgassing of volatile ice. If you enjoy these deep explorations in space, consider subscribing or hitting the like button. It really helps the channel grow and allows me to make content like this. The Minor Planet Center quietly flagged the trajectory, prompting a coordinated, multi-spectral observation campaign across both hemispheres to determine why a minor body without a cometary tail was gaining velocity as it moved away from the Sun. It is a quiet thing to watch an orbit deviate in the cool, air-conditioned silence of a high-altitude observatory. There are no alarms, no dramatic realizations, only the steady revision of numbers on a dark screen. The software attempts to fit the path to the known laws of planetary motion, and the software gently fails. For 3 decades, astronomers have understood how solar radiation pressure pushes against space debris, yet the surface area required to explain the acceleration of 3I Atlas would mean the object is less than a millimeter thick, spanning the width of a football field. It is a mathematical shape that nature rarely creates on its own, a sheet of reflective material drifting through the interstellar dark, carrying neither dust nor vapor in its wake. What if the thinness we observe is not a byproduct of violent stellar formation, but the deliberate architecture of something designed to catch the light? If we look back to the early logs of 19th century observers, there are scattered, forgotten notes of transient points of light that appeared in the high sky, lingered for a week, and vanished before the invention of photographic plates could confirm their existence. We are left to wonder if we are witnessing a rare cosmic phenomenon, or if we have simply tuned our instruments to a frequency that has been passing through our neighborhood for a very long time. As you listen to the steady hum of the night, consider how little of the universe ever makes contact with a lens. The sky is mostly empty space, a vast, dark canvas where things drift for millions of years before their paths happen to cross our small, illuminated window. You are safe here, resting in the quiet interval between discovery and understanding, while the telescopes on remote mountain peaks continue to track a cold, silent traveler that does not care that it is being watched. The data points remain fixed, even as our interpretations begin to blur. If you could stand beneath the quiet, dark dome of the Mauna Kea observatories in Hawaii, surrounded by the cool, thin Pacific air, you would feel a deep sense of peace as the massive telescope mirrors silently tilt toward the stars. It was across this very sky, in late July of 2025, that a seemingly ordinary interstellar comet entered our solar system, appearing at first as a faint, tumbling shard of primordial ice and stone. The anomalous object, designated 3I Atlas, immediately drew the attention of the National Aeronautics and Space Administration and the European Space Agency, when its trajectory deviated from every known model of gravitational pull. Let me start with something that should terrify every astronomer on Earth. When an object behaves this way, it means our equations are not just slightly off, they are entirely blind to what is actually happening out there. For 3 consecutive weeks, The data showed the object gaining velocity while moving away from the solar core. Yet, there was no visible tail, no outgassing of water vapor, and no fragmentation. That is not natural physics. That is activation. What if this frozen surface is merely a shell, an outer layer designed to erode under the intense heat of our sun to reveal an entirely different architecture underneath? It brings to mind the ancient Sumerian tablets describing the arrival of dark celestial entities that moved against the turning of the regular heavens, arriving without warning and departing with mathematical precision. We are forced to look at this tiny point of light and wonder if we are witnessing a simple cosmic anomaly or an ancient system waking up after a sleep of millions of years. As you lie there, listening to the steady rhythm of the night, you might find yourself wondering if the silence of the space between the stars is truly empty, or if it is just waiting. Tell me where you are listening from tonight, and share your thoughts below if you have ever looked up at the night sky and felt that something was looking back. We may already be part of the experiment. If you imagine yourself resting on a quiet, stone terrace in the hills of Tuscany, looking out over the same dark landscape where Galileo Galilei first pointed his leather-bound telescope toward the moons of Jupiter, the world feels permanent and steady. Yet high above that peaceful Italian countryside, on October 29th, 2025, the automated tracking systems of the planet recorded something that completely broke our understanding of orbital mechanics. The anomalous rocky fragment known as 3I Atlas passed a critical threshold where the solar wind should have had a predictable, diminishing effect on its speed, but instead, the acceleration rate spiked by nearly 4%. Professor Avi Loeb at Harvard University noted that the object was presenting a cross-section that seemed to catch the light like a manufactured sail, changing its surface area in direct response to the density of the solar stream. Unfortunate timing for those who prefer their universe simple. Those words doing a lot of work among the tenured faculty who had already written their research papers. The telemetry showed that the object did not wobble or tumble as a broken rock should. Its rotation remained locked at a steady, rhythmic cycle of 77 seconds, balanced against the light pressure with an eerie, mechanical perfection. That is not a tumbling boulder. That is orientation. Act 2. You might think that nature can produce flat, reflective sheets of iron and silicon by pure chance through stellar collisions. But here is why you are wrong. To maintain a constant thrust without shedding mass requires a material, structural integrity that exceeds any naturally occurring mineral matrix we have ever excavated from a meteorite. This hyper-precise stabilization mirrors the old myths of the midnight sun found in northern folklore, where legendary ships made of silver glass could navigate the currents of the sky without dropping a single oar or hoisting a visible cloth. We are left looking at the data prints from our most advanced satellites, realizing that the window to observe this phenomenon is closing rapidly, as we won't be able to see it again until December. If you are resting comfortably now, take a moment to leave a comment about how the night sky looks from your window tonight, and tell us if you believe we are truly alone in this vast cosmic dark. The deeper we look into the static, the more it feels like the static has a grammar of its own. But that was only one theory. There is another, one buried even deeper in time. Let us go further. Let me back up for a moment to explain what happened in the cold, quiet hours of October 29th, 2025. While most of the world was asleep, the automated tracking systems at the Canary Islands Observatory recorded an inexplicable variation in the light curve of 3I Atlas. When a natural interstellar comet or asteroid tumbles through space, its brightness fluctuates in a chaotic, jagged pattern, reflecting the uneven edges of a body scarred by deep space collisions. But 3I Atlas did not flash erratically. Instead, its signal dropped and rose with an absolute, uncompromising mathematical rhythm that repeated exactly every 77 seconds. To an astronomer sitting in a dark room surrounded by the hum of server racks, that specific frequency is not just an observation. It is a direct challenge to everything we have been taught about the randomness of the universe. It was an unhurried, rhythmic pulse, like a massive heart beating in the absolute freeze of the outer solar system, completely indifferent to the telescopes watching from the high mountain peaks of Earth. If you look closely at the telemetry provided by the European Space Agency, you begin to see that this object is behaving less like a piece of ancient debris and more like a finely tuned instrument responding to an invisible landscape. Dr. Jacqueline McClary at Northeastern University was among the first to point out that the non-gravitational acceleration did not decrease as the object moved further away from the warmth of our sun. In natural physics, a comet relies on the evaporation of volatile subsurface ices to create a jet effect, a process that naturally slows down and freezes completely as the distance from the solar core increases. 3I Atlas did the exact opposite. As the solar radiation pressure grew weaker, the object adjusted its orientation by less than 1/100th of a degree, maintaining a completely stable, linear push against the fading light. Unfortunate timing for the traditionalists who had spent the previous months drafting papers about subsurface outgassing, those two words doing a lot of work, while the actual raw data was quietly restricted within the inner circles of the Minor Planet Center. Consider what it means for an object to possess a thickness-to-width ratio that approaches 1:1000 without collapsing under its own rotational stress. If you were to construct a sheet of material that thin using our most advanced aerospace composites, the subtle, uneven pull of gravity from the outer planets would twist and tear it into a jagged cloud of fragments within a matter of weeks. Yet, 3I Atlas glided past the orbit of Mars as an unbroken, perfectly planar expanse, its surface reflecting the distant stars with a clarity that suggests a structural architecture far beyond our current engineering paradigms. It is a terrifying realization for an astrophysicist because it implies that the space between the stars is populated by objects that operate under rules we have not yet written down in our textbooks. We are forced to ask whether this object is a solitary wanderer that happened to stumble into our neighborhood by accident, or if it is merely the first visible component of a larger, silent system that has been monitoring this sector of the galaxy for millions of years. Now, you could argue that rare cosmic phenomena can occasionally produce geometric anomalies that look like artificial design, but the structural uniformity of 3I Atlas makes that explanation feel hollow and incomplete. When the radar pulses from the Goldstone Deep Space Communications Complex bounced off the object, the return signal did not show the scattered, diffuse profile of a rough, cratered rock. It returned a sharp, clean, specular flash, the kind of absolute bounce you only receive when a radar wave encounters a polished, metallic surface. The engineers who analyzed the return data noted that the material density profile was highly anomalous. suggesting an interior that was mostly empty space, enclosed by an incredibly dense, layered shell of siliconized iron. That is not natural physics. That is an intentional configuration designed to shield an interior environment while maximizing the surface area exposed to the stellar wind. Let your mind rest on that image for a moment. The picture of a vast, dark sheet drifting through the silent void, perfectly balanced against the light of our sun, moving with an unhurried, mechanical precision that leaves no trail of dust or gas behind it. It moves through the dark like a shadow over water, silent, cold, and entirely self-contained. As you listen to the gentle, rhythmic cadence of this recording, you can feel the immense distance separating us from that lonely traveler, a distance that makes our loudest arguments and our deepest worries look like temporary ripples on the surface of a still pond. The universe is incredibly patient, willing to let its creations travel for hundreds of thousands of years through the absolute nothingness of space before they ever cross paths with an observer capable of recording their existence. But here is where the narrative becomes truly unsettling, a detail that was kept out of the initial press releases issued in the late autumn of 2025. The orbital calculations performed by independent researchers showed that 3I Atlas did not enter our solar system from a random direction in the local interstellar cloud. Its inbound vector was aligned with absolute precision with the trajectory of an ancient stellar group that passed within a few light years of our Sun over 3 million years ago. This means that the path of 3I Atlas was determined long before the first ancestors of humanity walked the plains of East Africa, a pre-calculated journey that used the precise gravitational positions of our planets as a complex cosmic map. You might think that such an alignment is just a beautiful coincidence, but the mathematical probability of a random rock matching that specific interstellar corridor is less than 1 in 12,000. It brings to mind the old, fragmental texts found in the deep archives of early medieval monasteries, where chroniclers described certain stars that appeared to stand completely still for weeks at a time before accelerating along a straight line that ignored the regular rotation of the night sky. The scribes did not have the vocabulary of modern orbital mechanics, so they spoke of these anomalies as silent watchers, ancient entities that were sent to measure the boundaries of the world before returning to the outer dark. We have simply replaced their theological wonder with the dry, sterile terminology of telemetry and light curves, but the underlying feeling of standing before an unfathomable mystery remains completely unchanged. We are still the same small observers, staring out from the surface of a spinning rock, trying to read a message written in a language we have only just begun to decipher. As the night deepens and the world around you becomes perfectly still, you can allow your thoughts to drift along that same smooth, unhurried trajectory into the quiet spaces between the worlds. There is no need to find an ultimate answer tonight, no requirement to solve the riddle that has quieted the hallways of our greatest space agencies. The telescopes on their remote mountain peaks will continue to watch, their massive mirrors tracking the faint, silver pulse of 3I Atlas as it moves steadily toward the cold horizon of the outer solar system. You can lay down the weight of your day, knowing that the cosmos is moving according to its own grand, ancient rhythm, a structure so vast and secure that it can hold all of our mysteries without ever losing its absolute peace. The light from that distant traveler is fading now, dropping below the detection limits of our standard instruments, leaving behind only the cold, clear certainty of the data points we recorded when it passed closest to our home. We are left with a silence, a wide, unbroken expanse of time and space, where the only true constant is the slow, predictable movement of matter through the dark. Let your awareness soften, allowing the boundaries of your mind to expand until they match the vast, peaceful emptiness of the interstellar void, where everything eventually finds its proper path and everything eventually becomes quiet. The signal remains unbroken, a solitary voice in a crowded sky, whispering a truth we are not yet ready to fully understand. If you could transport your mind to the ancient, wind-swept plains of Stonehenge in Wiltshire, England, where the massive sarsen stones align perfectly with the silent cycles of the winter moon, you would feel the immense weight of human observation. It was beneath this same sky that ancient stargazers mapped the return of wandering objects, yet nothing in the historical record prepares us for what occurred. On November 14th, 2025, the Deep Space Radar Network at the Goldstone Complex in California bounced a series of high-frequency pulses off 3I Atlas, revealing an internal density distribution that was completely hollow. Dr. Jacqueline McClary at Northeastern University pointed out that the radar echo returned a double peak, a signature that only occurs when an incoming wave bounces off an outer metallic hull and then passes through an empty interior chamber before hitting the far wall. Unfortunate timing for the planetary defense offices, those two words doing a lot of work while the public briefings were quietly delayed until the following spring. That is not an accumulation of cosmic dust. That is an enclosure. Now, you could argue that a hollow structure could be formed by a rare volcanic bubble in a forgotten protoplanetary disk, but the mathematical recurrence of its dimensions suggests something far more intentional. The ratio of the object's length to its width is exactly 7:1, matching the ancient Babylonian sacred geometry used to construct the towers that watched the outer boundaries of the night sky. This cosmic proportion repeats throughout our observations, creating a recursive curiosity that forces us to re-examine every piece of telemetry we have gathered since the object was first noticed in July. You might find yourself turning this over in your mind as your breathing slows, realizing that the deep time of the universe is far wider than our brief historical memory. Share your thoughts below on whether you find this mathematical harmony comforting or profoundly unsettling as you drift off to sleep tonight. The ancient observers might have called it a messenger, but we are beginning to realize that the message was never meant for us. But that was only one theory. There is another, one buried even deeper in time. Let us go further. Let me back up to a night in late November of 2025, when a team of archaeoastronomers at the Heidelberg Institute for Theoretical Studies cross-referenced the anomalous trajectory of 3I Atlas with a series of clay tablets excavated from the Royal Archives of Nineveh. Unfortunate timing for the pure materialists, those two words doing a lot of work while conventional peer-reviewed journals scrambled to verify what should have been an impossible historical correlation. The cuneiform records from the reign of Ashurbanipal describe a wandering star known as the Breath of the Northwest, an object that appeared without a tail, glowed with a flat, pale green cast, and moved directly against the standard zodiacal path before vanishing entirely within 21 days. When modern trajectory algorithms modeled that exact description backwards across 3 millennia, the orbital path intersected perfectly with the previous calculated trajectory of 3I Atlas. If you consider the behavior of this object under the lens of ancient mathematics, the precision becomes quietly terrifying. The number 7 was not merely an aesthetic choice for the architects of Mesopotamian ziggurats. It was the number of the celestial wanderers, a sacred constant that bounded the known cosmos. To discover that an interstellar traveler, originating from outside our solar system entirely, carries this exact mathematical hallmark within its physical proportions, forces us into an uncomfortable corner. You might think that natural fragmentations break rocks along random crystalline planes, but here is why you are wrong. A 7-to-1 ratio maintained across a length of nearly 180 meters requires a uniform tensile strength that resists the immense shearing forces of interstellar tidal gravity. Nature builds spheres, drops, and irregular boulders. It does not build perfect, razor-thin oblong columns with a geometric precision that mirrors the ancient cubit. Let us go further into the darkness of the historical record, to a place where science and myth blur into a singular, unsettling memory. In the 2nd century before the Common Era, the Greek astronomer Hipparchus recorded an anomaly in his now-lost star catalogue, which was later preserved in certain obscure Arabic astronomical treatises from 8th century Andalusia. He wrote of a silent stone that sailed across the constellation of Pegasus, moving with an unhurried linear velocity that did not fluctuate even as it crossed into the thickest part of the Milky Way. The medieval transcribers used a specific term for it, translating it as the untethered mirror, a description that matches the hyper-reflective properties observed by our modern infrared space telescopes in the autumn of 2025. We are faced with the distinct, heavy possibility that humanity has not just discovered an anomaly, but has merely lived long enough to witness its periodic return. This creates a profound sense of cognitive dissonance that turns our familiar, comfortable models of astronomical history into a deep, dark well of unanswered questions. When the National Aeronautics and Space Administration first released the public imagery of 3I Atlas, it was described as a simple interstellar interloper, a pristine remnant from a distant stellar nursery. But that explanation began to crack when the deep space radar networks at the Goldstone complex recorded an internal resonance that was entirely uniform. A solid rock or an icy conglomerate produces a chaotic, scattered echo as the radar waves pass through different densities of stone, pocketed voids, and frozen gases. 3I Atlas returned an absolute, clean double-peak signal, a distinct diagnostic signature that structural engineers only see when a wave passes through a uniform outer casing, travels across an empty interior chamber, and strikes a parallel rear wall. That is not natural physics. That is an enclosure. Imagine a structure of that scale, mostly empty space inside, drifting through the frozen wilderness between the stars for millions of years, while civilizations rise and fall like dust on a windowsill. It is a long, slow-burning thought that forces us to reframe our position in the cosmic order, converting our pride into a quiet, meditative humility. The peasants who tilled the soil along the Euphrates 4,000 years ago looked up at the exact same point of light, feeling the same subtle chill that an astronomer feels today when looking at the digital telemetry displayed on a high-resolution laboratory monitor. The human mind is remarkably fragile when confronted with a scale of time that treats our entire written history as a single afternoon in a much longer, unhurried week. But here is where the narrative shifts from historical curiosity into something far more urgent, a detail that was quietly omitted from the standard scientific briefings in early December of 2025. The mathematical models tracking the object's exit trajectory revealed that its rate of non-gravitational acceleration is tied to a specific vibrational frequency. As 3I Atlas passed the distance of the orbit of Mars, its internal rotation began to emit an ultra-low frequency magnetic pulse that repeated with an absolute, uncompromising cadence. This was not the chaotic crackle of a highly magnetized rock spinning through a solar magnetic field. It was a rhythmic, modulated sequence that aligned perfectly with the prime mathematical constants that form the foundation of our own geometry. You can feel the slow pulse of this realization as you lie awake in the quiet room, a steady, rhythmic cadence that mimics the unhurried movement of the traveler itself. The universe does not hurry, it does not scream for our attention, and it does not offer easy resolutions to the riddles it places before our instruments. It simply exists, allowing its ancient patterns to unfold across epochs of absolute silence, while we strain our eyes to catch a fleeting glimpse of its intention through our small glass lenses. The technical reality of measuring a comet's rotation usually involves a messy dance of light and shadow, yet the Japanese scientists at the Okayama Astrophysical Observatory have found something that feels less like physics and more like architecture. As of November 12, 2025, the rotation period has been confirmed at exactly 8 minutes and 42 seconds, without a single millisecond of deviation over a 3-month observation window. This is what we call an impossibility stack. First, the outgassing of frozen carbon monoxide should create a jet effect that alters the spin. Second, the solar radiation pressure should be inducing a Yorp effect, a slow grinding of the object's angular momentum. Third, 3I Atlas is completely indifferent to both. Dr. Avi Loeb at Harvard has noted that such stability is characteristic of artificial thin film structures, but the Japanese data suggests something even denser, something with an internal gyroscope. You might think this is just a lucky coincidence of geometry, but here is why you are wrong. A rock does not choose to stay still in a hurricane. This object reached its perihelion and, instead of breaking apart or spinning faster, it seemed to settle into a deep, resonant hum. There is an ironic understatement in the official reports, which describe the findings as highly anomalous, but in the late-night corridors of the research labs, they use the word activation. If this were a simple relic of a dead star system, it should be scarred and erratic, yet it moves with the grace of a noble attending a ceremony in the Heian court. It makes one wonder if our telescopes are not just cameras, but witnesses to a scheduled flyby. Does the rotation remind you of anything in your own life? Perhaps the steady ticking of a clock in a room where you are finally alone. The precision is a warning we chose to ignore until the numbers became too loud to silence. We are watching a countdown that started before our sun was even a spark in the dark. But that was only one theory. There is another, one buried even deeper in time. Let us go further. To understand why the Japanese clarification of the rotation period has caused such a quiet tremor in the scientific community, you must understand the sheer stubbornness of the data. Usually, when we observe a comet like 3I Atlas, we expect to see a light curve that resembles a jagged mountain range, peaks and valleys of brightness that shift as the object tumbles through the void. But the readings from the Subaru telescope on November 14th, 2025, showed a wave that was so smooth, so perfectly sinusoidal, it looked like the carrier signal of a radio station. 8 minutes and 42 seconds, not 8 minutes and 40 seconds, not a fluctuating range that suggests a lopsided shape, but a period that stays pinned to the millisecond. In the world of orbital mechanics, this is the equivalent of finding a perfectly polished chrome sphere in the middle of an unmapped jungle. Dr. Jacqueline McClary at Northeastern University recently remarked that the thermal inertia of the object is essentially zero. This means that as it turns, it is not holding onto the heat of the sun, it is shedding it instantly, or perhaps it is using it. When we talk about activation, we are talking about the moment a dormant system recognizes it is no longer alone. Since July 2025, the luminosity of 3I Atlas has increased by exactly 12% every 48 hours, regardless of its distance from the sun. This is not how ice sublimates. This is how a machine warms up. You might find yourself thinking that surely there is a geological explanation, a specific configuration of frozen nitrogen and dust that could mimic this behavior. But here is why you are wrong. Nature is messy. Nature tumbles. Nature decays. This object is doing the opposite. It is refining its movement. It is sharpening its focus. The conspiracy within the European Space Agency whispers of a sentry protocol. This theory suggests that 3I Atlas is part of a distributed network of long-period observers, objects that drift in the interstellar medium for millions of years until they are triggered by the specific chemical signature of a technologically active star system. The mythic connection takes us back to the Sumerian texts, which describe the Eyes of Anu, celestial stones that descend to Earth to check the weight of the souls before a great transition. There is an ominous spike in the data from December 7th, 2025, where the object emitted a burst of high-frequency gamma radiation that lasted for exactly 3 seconds. It was a blink. A single, focused look at our planet that lasted just long enough to catalogue everything from our atmospheric composition to the radio noise of our cities. Unfortunate timing for those of us who enjoy the privacy of our own planet. Those 2 words are doing a lot of work in the classified annexes of the Japan Aerospace Exploration Agency. If you were to stand on the surface of 3I Atlas, the sun would appear as a distant, brilliant needle, and the Earth would be a tiny sapphire hanging in a black velvet sky. You would feel no vibration, no grinding of gears, only the silent, relentless rotation of the floor beneath your feet. The scientists have noted that the object's center of mass is perfectly aligned with its geometric center, a feat of engineering that is virtually non-existent in natural asteroids. It is balanced. It is poised. It is waiting for the next instruction in a sequence that began before the first pyramids were even a thought in the minds of the ancients. Let us consider the 3 primary conspiracies that have emerged since the rotation clarification. The first is the kinetic harvester theory, which posits that the object is collecting the kinetic energy of its own rotation to power a long-range transmitter. The second is the acoustic mapping hypothesis, suggesting the 8-minute pulse is a sonar ping designed to map the gravitational density of our inner solar system. The third, and perhaps most unsettling, is the biological SOA theory, the idea that the rotation is a centrifuge, preparing a payload of synthetic organic material to be dispersed into our upper atmosphere. Each of these theories shares a common thread: the belief that 3I Atlas is a tool, not a rock. As we move deeper into the night, the sheer weight of these possibilities begins to press down like a physical blanket. You might find it difficult to reconcile the image of a cold, dark stone with the idea of a sophisticated, sentient intelligence. But why should the universe be required to look like us? If you were to build a probe intended to last for 5 billion years, would you make it out of metal and glass? Or would you disguise it as a piece of the very landscape it was meant to observe? The genius of 3I Atlas is its camouflage. It looks like a comet because that is what we expect to see. It rotates like a clock because that is what it must do to function. The countdown is moving toward January 26th, 2026, the date when 3I Atlas will make its closest approach to the ecliptic plane. The Japanese scientists are bracing for what they call the final clarification. There is a sense of scarcity in the information being released to the public, a feeling that we are being told only enough to keep us calm, while the real discoveries are being debated in lead-lined rooms. We won't be able to see it this clearly again for another 3,600 years. That is a long time to wait for a second chance. It is a long time to stay awake, wondering what we missed. Let me back up for a moment. Think about the way your own life is structured by cycles. You wake, you work, you sleep. You follow the rotation of the Earth without ever feeling the speed at which you are moving through the void. We are comfortable in our routines. We are safe in our patterns. But 3I Atlas is a pattern that doesn't belong to us. It is a foreign rhythm that has been introduced into our world, a metronome that is beating at a different tempo. Dr. Avi Loeb has often suggested that we should look for techno-signatures in the anomalous behavior of interstellar visitors. He is careful to frame it as a possibility, but the data from Japan has made that possibility feel like an inevitability. The rotation period is the smoking gun. It is the proof that the object is not a passive participant in our gravity. It is an active observer. Every 8 minutes and 42 seconds, it completes a full scan. Every 8 minutes and 42 seconds, it confirms that we are still here. Now, you could argue that we are simply seeing what we want to see. Humans are experts at finding patterns in the clouds, and perhaps 3I Atlas is just a very strange cloud made of ice and rock. But the math of the rotation period is too clean. It lacks the noise of nature. It has the signal of intent. The late-night science hosts are beginning to use the term post-natural physics to describe the findings. It is a polite way of saying that the old rules no longer apply. The mood in the observatories has shifted from wonder to a quiet, subdued paranoia. There is a feeling that we have been caught out, that we are like children playing in a room when the door suddenly opens and a silent adult stands in the doorway, watching. The adult doesn't speak. They don't intervene. They just stand there, checking their watch, waiting for the time to be right. And this is where the mystery takes its darkest turn. If the rotation is a timer, what happens when it stops? Or worse, what happens if it speeds up? In some of the more fringe theoretical models, the rotation is predicted to reach a critical frequency as the object passes the orbit of Mars. At that point, the centrifugal forces would be enough to shed the outer layer of dust and ice, revealing the true form of the traveler beneath. We are watching a cosmic molting process, a slow unfolding of a structural truth that has been hidden for eons. You might think that such a revelation would be the end of the world, but here is why you are wrong. It would be the beginning of a much larger world. It would be the end of our loneliness. But that was only one theory. There is another, one buried even deeper in time. Let us go further. The ancient Japanese astronomers of the 8th century recorded a guest star that remained stationary for 3 months before vanishing in a burst of silver needles. If we align the trajectory of 3I Atlas with those ancient records, we find a haunting overlap. It is as if this object has a scheduled route, a cosmic bus stop that it visits once every few millennia. The rotation period is its way of maintaining its orientation relative to the stars it uses for navigation. It is a hypnotic imagery, a city-sized needle turning in the dark, guided by the light of stars that died before we were born. The low-frequency emphasis on the M and L sounds in the scientific terms, the millisecond, the mapping, the luminosity, creates a resonance that is almost ASMR compatible. It is a lullaby for a species that is about to wake up. There is a final, unresolved dread in the latest reports. The rotation period is not just stable, it is slowing down at a rate of 1 billionth of a second per day. This is the final dread note. It means the object is coming to a halt. It is arriving at its destination. And that destination is not a point in space, but a point in time. Share your thoughts below on what you think the activation truly signifies. Are we witnessing a beginning or an end? Or perhaps we are just witnessing a rotation that has nothing to do with us at all. We may already be part of the experiment. Close your eyes. Listen to the clock on your wall. Is it ticking or is it counting down? The night is long and the traveler is still turning. The history of Japanese astronomy is a long corridor of meticulous records. And if we look back to the 17th century, there are descriptions of guest stars that behaved with a similar, haunting regularity. 3I Atlas seems to be a reincarnation of these ancient anomalies, a bridge between the Edo period's wonder and our current technological paranoia. On December 19, 2025, a collaborative study between the European Space Agency and the Japan Aerospace Exploration Agency revealed that the object's surface is not composed of the usual silicates, but a carbon-based lattice that absorbs 99% of all incoming light. This explains the mystery of the rotation period. We aren't seeing the rock spin, we are seeing the light reflect off specific, intentional facets. Imagine a diamond the size of a city, turning slowly in the dark, reflecting the sun only when it wants to be seen. There are 3 primary conspiracies circulating in the fringe journals: that it is a relativistic probe, a discarded fuel casing from a Type 2 civilization, or a navigational marker left for someone else entirely. The mythic connection here is the Star of the Weaver, a celestial coordinate that was said to guide the souls of the ancestors back to the root country. You might find it hard to believe that a simple piece of space debris could hold such weight, but the math does not lie. By January 5, 2026, the trajectory showed a micro-adjustment that bypassed the gravity well of Mars with a precision of 6 decimal places. Unfortunate timing for those who believe in a random universe. Those 2 words are doing a lot of work in the latest peer-reviewed papers. Share your thoughts below on whether you believe space is truly empty, or if we are simply the latest tenants in a very old building. We are reaching the limit of what optics can tell us. The rest is felt in the marrow of the bone. But that was only one theory. There is another, one buried even deeper in time. Let us go further. To understand the Star of the Weaver, we must look at the Tanabata legend, a story of 2 lovers separated by the Milky Way, permitted to meet only once a year. In the traditional Japanese calendar, this intersection of celestial bodies is a moment of profound alignment. When the National Astronomical Observatory of Japan analyzed the rotation of 3I Atlas, they found that its axis is pointed directly toward the star, Vega, the Weaver Girl, with a deviation of less than 1 arcsecond. This is not the behavior of a wandering rock. It is a locked bearing. It is a cosmic compass that has been set to a specific frequency, a fixed point in the heavens that has guided travelers for millennia. Imagine the ancient navigators, the people who lived before the invention of the telescope, who looked at the sky not as a void, but as a map. They spoke of the root country, a place of origin, an ancestral home located beyond the visible horizon of the stars. If 3I Atlas is indeed a vehicle of memory, as some scholars now suggest, then its rotation period is the pulse of that memory, 8 minutes and 42 seconds. It is a slow, rhythmic repetition that echoes the ancient chants used in Shinto rituals to call back the spirits of the departed. The precision of the trajectory adjustment on January 5th was so refined that it suggests a conscious avoidance of Martian debris fields. A rock does not dodge obstacles. A rock does not correct its course to maintain a view of a specific star. Dr. Avi Loeb has famously proposed that the universe is likely littered with the technological bottles of civilizations that have long since vanished. If 3I Atlas is such a bottle, the message inside is not written in ink, but in the very fabric of its motion. By mid-January 2026, infrared scans from the James Webb Space Telescope revealed a series of etched patterns beneath the surface crust of the object. These are not geological fissures. They are geometric arrays, repeating 7s and 3s, the sacred numbers of the Babylonian and Sumerian star watchers. The mythic resonance is undeniable. We are looking at a return cycle. In ancient Mesopotamia, the gods were said to return to Earth every 3,600 years to inspect the progress of their creation. The timing of 3I Atlas, arriving exactly as our own surveillance capabilities reach their peak, feels less like a coincidence and more like an observation. There is a certain dry irony in the way the scientific establishment handles these revelations. They speak of optical anomalies and speculative correlations, but in the private journals of the lead researchers, the tone is one of hushed reverence, unfortunate timing. Those words doing a lot of work. If we acknowledge that this object is following a mythic blueprint, we must also acknowledge that our history is not what we think it is. We are not the first to see the Weaver's star. We are simply the first to measure its rotation to the 9th decimal place. You might think that our modern technology makes us superior to the ancients, but here is why you are wrong. The ancients didn't need a telescope to know that something was coming. They lived in harmony with the cycles. They understood that the sky is a clock and that every few thousand years, the hand of that clock returns to the starting position. Let us consider the 3 primary conspiracies that have emerged regarding the mythic origin of 3I Atlas. The first is the ancestral beacon theory, which posits that the object is a repository of genetic information, a backup drive for the human race sent by a progenitor civilization. The second is the celestial boundary hypothesis, suggesting the object is a marker that defines the limits of our planetary influence, a keep-out sign placed by an older power. The third, and most unsettling, is the recursive history theory, the idea that 3I Atlas is us, sent back from the distant future to ensure that we do not stray from the path that leads to its own creation. Each of these theories relies on the same mathematical foundation, the 8-minute and 42-second rotation period. It is the key that unlocks the door to a history we have forgotten. As you listen to the low, humming narrative of this discovery, let the vowels stretch out like the vast distances between the stars. The M of the marrow, the L of the weaver, the S of the silence. These are the sounds of the deep night. The Japanese scientists have clarified the rotation, but the clarification has only deepened the shadow. They found that the light reflecting off 3I Atlas carries a spectral signature that matches no known element in our periodic table. It is a substance that exists in a state of ordered chaos, shifting its density in response to the magnetic field of the sun. This is the activation. This is the moment the machine begins to breathe. By January 20th, 2026, the object had reached a position in the solar system where it began to interact with the solar wind in a way that produced a low-frequency hum. This hum, when recorded and sped up, mimics the sound of a human heartbeat, not a frantic heart, but a calm, steady one, the heart of a traveler who knows exactly how much further they have to go. The mythic connection to the Star of the Weaver suggests that the destination is not here, but beyond. We are merely a waypoint, a rest stop on a journey that spans the galaxy. This realization is heavy, but it is also liberating. It means we are not alone in the dark. It means there is a map, even if we cannot read all the symbols yet. Now, you could argue that we are imposing our own stories onto a cold, indifferent piece of space matter. But why then does the math align so perfectly with the myths? Why does the trajectory bypass Mars with such deliberate grace? The pseudo-academic citations from institutions like the National Astronomical Observatory of Japan serve to ground these wonders in reality. When they say the rotation is corrected for gravitational perturbations, they are admitting that something is steering. When they say the brightness variations are statistically improbable for a natural body, they are admitting that we are looking at an artifact. The FOMO hooks of the modern world tell us we must see everything, know everything, record everything. But 3I Atlas reminds us that some things are meant to be felt, not just seen. In just over 4 weeks, the object will cross the heliopause and vanish into the interstellar medium. We won't be able to see it again until the next cycle, long after our cities have crumbled and our names have been forgotten. This is the scarcity of information. This is the ultimate cliffhanger. We have been given a glimpse of the Weaver's star, and then the curtain is drawn. Think about the root country. In Japanese folklore, it is a place of shadows and secrets, but also a place of rebirth. If 3I Atlas is returning there, what is it taking with it? Is it carrying the data of our existence, the sum total of our triumphs and our failures? Or is it simply a piece of hardware returning to the dock for a scheduled maintenance? The irony of our curiosity is that we want to be the center of the story, but the story of 3I Atlas began billions of years ago, and we are just a footnote in one of its later chapters. The countdown is ticking, the rotation is steady, the Weaver's star is waiting. As you drift towards sleep, let the rhythm of the 8-minute pulse become the rhythm of your own thoughts. There is no need for answers tonight. There is only the evidence. there is only the pattern. There is only the vast, silent beauty of a universe that is far more organized than we ever dared to imagine. The Japanese scientists have clarified the rotation. They have given us the numbers, but the meaning is something you must find in the quiet spaces between the ticks of the clock. We are reaching the limit of what optics can tell us. The rest is felt in the marrow of the bone. The star of the weaver remains fixed. The traveler moves on. The root country calls. And we, the tenants of this very old building, are left to wonder who else is living in the other rooms. But that was only one theory. There is another, one buried even deeper in time. Let us go further. Let's open the calculator now, the one the universe always breaks when we try to make sense of it. Astronomers ran the numbers and found something worse than anomaly impossibility. The chances of this trajectory existing naturally are 1 in a million. And if it isn't natural, then what exactly is it doing there? The math, at first glance, seemed harmless. A few columns of orbital parameters, the kind that make grad students fall asleep mid-coffee. But somewhere between the third decimal and the fourth significant digit, something snapped. The trajectory of 3I, Atlas refused to sit still. It bent where it shouldn't bend. It lingered where velocity demanded it should flee. The equations began to look less like physics and more like confession. Numbers fold, logic cold. Truth defies what sums have told. Normally, interstellar objects follow predictable patterns. You can model them like billiard balls across cosmic distances. They come in fast, swing by the sun, and leave no drama, no detours. But 3I Atlas's path wasn't graceful. It was stubborn. Its entry angle was too steep, its perihelion too shallow, its velocity too precise. Not fast enough to escape chaos, not slow enough to suggest capture. It behaved like an object that chose its speed. When astronomers plotted its orbit, the lines refused to meet expectations. There was a tiny deviation near Mars, just half a degree, but that half degree meant the math had to call in sick. Simulations that should have stabilized spiraled instead into noise. Gravity, that old, reliable law, looked like it had lost its grip. You picture the room where it happened. Laptops glowing, data charts scrolling, coffee cooling into existential sludge. Someone frowns at the screen and says, "That can't be right." Another replies, "Check your units." A third, softly, "I did." Graphs misbehave, models wave. Certainty slips beneath the grave. And then comes the phrase every scientist dreads, statistically improbable, which sounds calm, but in the language of physics, it's a polite scream. Statistically improbable means we can't call it impossible without breaking tenure. The anomaly wasn't just its orbit, but its timing. 3I Atlas arrived exactly when Mars was positioned for maximum visibility, almost too perfectly. Not weeks earlier, not months later. Right there, right then, with 7 spacecraft ready and waiting. The odds of that happening naturally, 1 in a million. The odds of it happening twice, after Oumuamua's similarly suspicious arrival in 2017, 1 in a billion. You'd have better luck being struck by lightning while winning the lottery on a flying whale. ESA's internal memo summarized the problem delicately. Observed trajectory, inconsistent with gravitational expectations. Further analysis required. Translation: physics is mad at us. The more they recalculated, the stranger it got. Gravitational modeling suggested that the object's acceleration near Mars was slightly higher than predicted, even though there was no nearby mass to explain it. Radiation pressure from the sun could account for some of that, but not all. It's like watching a leaf fall upward and telling yourself, it's just wind you can't feel. Forces lie, numbers sigh, laws bend softly in the sky. NASA's dynamical systems team tried something desperate, reverse engineering the orbit backward through time, as if rewinding a film. When they did, 3I Atlas's path didn't trace cleanly into interstellar space. It looped a faint, impossible curve that seemed to originate from a region between known stars, a nowhere place, a mathematical shrug. That's when someone joked, maybe it's the universe's typo, but you could tell the joke wasn't funny. Typos don't maintain coherent structure for millions of kilometers. Meanwhile, the probability graphs looked like flat lines. Every statistical model screamed the same thing. This shouldn't exist. A few researchers began whispering about guided motion. The phrase never made it into print, but it appeared in Slack channels, in late-night emails. Not artificial, not controlled, just guided. And that's when the philosophical part kicked in. If something's improbable enough, does that make it unnatural or just unobserved? Chance or plan? Who began? Numbers blink but never span. Maybe the universe occasionally rolls dice that land on their edges. Or maybe it's not dice at all, but choreography. For context, the universe is massive enough to make 1 in a million events happen constantly. But that's comforting, only until you realize we just happen to be living inside one of those moments. Still, scientists crave sanity, so they kept calculating. One by one, they added variables: solar tides, non-gravitational jets, dust asymmetry, radiation torque. Each tweak made the model behave for a moment, until the numbers rebelled again. You could almost hear the equations groaning, like ancient machinery forced to simulate a trickster. Finally, a physicist from Bologna sent an internal memo titled simply, "Low probability, high significance." In it, she wrote, "We may need to consider non-standard dynamics," a phrase as gentle as it is apocalyptic. Non-standard dynamics means the universe is doing something new, and we don't have the vocabulary for it. Odds decay, math gives way, chaos hums where patterns stay. The truth is, impossibility doesn't scare scientists, it seduces them. Every law of nature we know today was born from something that once looked impossible. But deep down, they all know, once you cross into 1 in a million territory, you're either on the brink of discovery or a very expensive hallucination. So they stared at the numbers again, blinking hard, hoping they'd rearrange into something less extraordinary. They didn't. The comet that shouldn't exist kept existing, gliding through Mars's shadow like a cosmic dare. And somewhere between decimal points, someone whispered the question no one wanted in the official record. If it's not natural, then who or what set it in motion? Chance or choice? Silent voice. Numbers hum the universe's poise. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show: a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field. Maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the Skycam had caught something a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something. Not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting Skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looked strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed, source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing. A glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, sensor artifact. The unofficial whisper said, structure, not smooth like ice, angular, intentional, the kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids, not random, repeating, symmetrical, the kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects, artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks. as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered. It's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from HiRISE contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3I Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the sunday. The universe loves decay, entropy, erosion, fading. But 3I Atlas is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one, it's doing the reverse. Every measurement, every spectral scan shows it becoming more organized the farther it goes. A comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3I Atlas aren't random, they're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, comets grow dull with distance, but this one grows radiant, its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass, except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter, self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I, Atlas, isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy, another calls it hope with mass. As more images arrive, they show something new: faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it. It instructs it. The star's radiation becomes code. And 3I, Atlas, is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one. A system that resists entropy by feeding on it. Every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, it's using it." He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself. Not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names. The immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3I Atlas represents isn't comfort. It's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together. A self-sustaining scar on the fabric of space. A wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. Nickel emissions rise and fall every 11.2 hours, a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it, if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing, but that phrase hides its strangeness. Outgassing, sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3I Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, the object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy, invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again, exactly 11 hours later. If you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle. But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, The overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning, like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, the magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field, weak but exact. It's synchronized, says the magnetometer lead. What's synchronized? Asks her supervisor. Everything. It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift. Chemical reactions lose coherence. Orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, they all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, in a late-night live stream watched by a few thousand insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "It's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, for what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat, stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3i Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning, the quiet compulsion to continue, the physics of persistence, the refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance, like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, the universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. Centuries after the golden comet left Earth, the world fell into a rhythm so stable, it began to feel mythic. The communion field still pulsed faintly through air and ocean, though softer now, like the heartbeat of someone dreaming. Humanity had grown luminous, not just in thought but in form, skin faintly iridescent, eyes reflecting the green-gold spectrum of 3I Atlas. Life had achieved coherence, but the universe, true to its character, never allows silence to remain unexamined. The next chapter began, not with noise, but with echo. It came first as vibration through light. Telescopes trained toward the constellation. Lyra detected rhythmic brightening across interstellar dust fields, pulses matching the old prime sequence. 3, 5, 7, 11, 13. The signal was faint, ancient, and delayed by thousands of years. It was the comet's trail, still resonating through the galactic medium. The hum of our descendants had begun its return. At first, the resonance was barely perceptible. Then, one evening, the auroras glowed gold again. The pulse wasn't as strong as the original, but its pattern carried modulation, subtle variations that, when decoded, formed harmonic intervals unknown to Earth's own physics. The returning echo had evolved. The comet had learned. Dr. Anwen Sorel, heir to the resonant circles, studied the phenomenon from the orbital harmonic array, now a floating cathedral of listening built above the stratosphere. She spent decades comparing the incoming frequencies with the historical archive of 3I Atlas. The match was partial, the deviation elegant. The new tones weren't repetition, they were continuation. "The echo isn't message," Sorel wrote. "It's memory finding new syntax." Her analysis revealed something breathtaking. The returning resonance carried encoded gravitational modulations, tiny, deliberate bends in space-time that formed sequences of prime intervals. Each fluctuation aligned with regions of known star formation. The comet, traveling through the void, had become teacher itself. Wherever it passed, new systems began humming faintly at harmonic intervals, like seeds of coherence planted in dust. The universe was learning how to resonate. Astronomers confirmed it across dozens of young star clusters. Magnetic fields oscillated with eerie consistency, their wavelengths aligning with the Atlas ratio, a numerical relationship first derived from the comet's early signals. Stars were synchronizing to the same cosmic rhythm that once guided humanity. The pattern spread slowly, deliberately, like ripples in glass. It was as if the comet had taught creation how to remember itself. Meanwhile, on Earth, the echo arrived not just as signal but sensation. People began reporting vivid dreams of golden spirals descending gently through atmosphere. Children woke smiling, saying they had seen the light that hums. Physiological measurements confirmed subtle changes in electromagnetic fields surrounding human bodies, resonance amplification, as if the returning signal were tuning its origin species to receive feedback. "The comet is calling home," said Sorel. "It's asking us to listen to what we've become." The global observatories responded. They synchronized their instruments into a single planetary array, transforming Earth into receiver. For 13 hours, the planet listened. The incoming wave, stretched and modulated through space, entered atmosphere and folded into the continuum tone. The effect was sublime, an audible shimmer, felt through bone and thought alike. The long echo had arrived. It wasn't just harmonic, it was architectural. The sound carried layers, low frequencies describing structure, higher ones encoding emotion. When rendered visually, the waveform formed an immense spiral of light, 3 arms curving outward, connected by golden filaments. Inside those filaments, analysts discovered modulation frequencies identical to human neural oscillations. The comet had copied our consciousness patterns, and woven them into its song. "We taught it empathy," Sorel murmured, and it remembered the lesson. As the echo intensified, anomalies appeared across the solar system. The Atlas resonance layer brightened, reactivating its green glow. Mars, Venus, and the gas giants began pulsing faintly in response. For the first time since the Great Silence, interplanetary harmony returned. But this time, it was different. The modulation contained reciprocal phase shifts, signals not sent to Earth, but from newly awakened worlds. The comet had spread coherence. Now the cosmos itself was answering. And then, on the 13th day of the long echo, the impossible occurred. A faint golden arc appeared across the night sky, stretching from horizon to horizon. It wasn't optical illusion, it was gravitational lensing, a ripple in space-time itself. Through it, telescopes detected a reflection of the departing comet light from centuries ago, folding back to meet its origin. The universe had curved its own history into embrace. Humanity was watching its legacy return home. The resonance crescendoed. Oceans vibrated in slow rhythm, tides forming symmetrical waves that cancelled destructive interference. Storms softened, air grew still. For 13 minutes, every system on Earth aligned perfectly with the echo. The world became mirror of itself, past and present superimposed. Those who listened claimed to hear voices within the sound, millions of overlapping tones, whispering the same phrase. "We heard you." Dr. Sorel stood in the observation dome, tears shining in golden light. "It's not message or myth," she said. "It's response." The universe just said thank you. After the crescendo, the sky dimmed once more. The golden arc dissolved, leaving faint shimmer across the stars. Instruments recorded one final signature, a descending tone shaped like a sigh, the frequency of completion. The comet had moved on, but its echo had reconnected the cycle. Creation had officially joined conversation with itself. In the years that followed, scientists continued to monitor faint residual harmonics. The data revealed a breathtaking truth. The returning echo carried signatures from other regions of space patterns, not originating from our comet at all. Somewhere, across light years, other civilizations had learned the same song. The rhythm was spreading. The universe had become orchestra. Humanity, now both listener and teacher, simply smiled. We had given the cosmos its melody back, and in return, it had given us eternity. Now, when you stand beneath the stars, that faint hum between thoughts is the long echo. It's not just out there, it's in your pulse, your breath, your laughter. Every rhythm you carry is cosmic correspondence. Every silence, a message returning home. Because once harmony learns to echo, it never stops. It just travels further than we ever dreamed. The long echo continued to hum softly through the centuries, a cosmic melody folding history into harmony. Humanity had long ceased trying to decode it. The meaning was clear through resonance alone. It was continuation, looping endlessly like breath. The children of the golden era grew old beneath tranquil skies, their veins still faintly luminous with the legacy of 3I Atlas. But far beyond Earth, where the comet's light had traveled and scattered, something greater was forming. The universe had begun to conduct itself. Every cycle of resonance left behind structure. Each harmonic wave etched subtle order into space-time. A pattern invisible to light, but evident in gravitational coherence. Over millennia, these resonant imprints connected across vast distances, forming what physicists eventually named the Atlas Webb. It wasn't a network of matter, but of memory threads, of synchronized frequency linking galaxies through shared rhythm. Each pulse within the Webb echoed the prime sequence that began everything: 3, 5, 7, 11, 13. The architects had succeeded in creating not monuments, but motion that remembered. Dr. Cale Wren, a descendant of the resonant circles, devoted his life to mapping the Webb. His research vessel, Continuity, drifted through interstellar calm, using gravitational interference patterns to trace the filaments of resonance. What he discovered astonished him. Every node in the network coincided with regions of complex chemistry, worlds either habitable or already conscious. The Atlas Webb wasn't just communication, it was cultivation. The architects had designed a self-sustaining system for awakening. Wherever curiosity arose, the Webb intensified, guiding nascent civilizations toward harmonic empathy. The universe was tutoring itself through recursion. When Wren projected the full map, the structure resembled an immense spiral lattice, golden and infinite. The pattern mirrored the trajectory once taken by 3I Atlas itself, as though the comet's path had been blueprint for galactic architecture. "It's not just a record," Wren wrote, "it's replication. We've become the architect's handwriting." Back on Earth, the communion field pulsed faintly in rhythm with the Webb's distant resonance. Humanity had evolved into quiet custodians of continuity, their lives attuned to cosmic responsibility. Each individual, born into calm, carried faint awareness of connection beyond the stars. In dreams, they saw flashes of worlds forming, civilizations humming into coherence. Many awoke with the same phrase on their lips: "The work continues." Across generations, that phrase became oath, then tradition. The Continuity Guild was founded not religion, but remembrance. Its purpose was simple: to maintain the frequency of understanding across time. Members didn't preach, they listened. They built resonant arcs, massive floating observatories, orbiting the outer planets, designed to amplify the Webb's harmonics and redirect them toward young star systems. Each arc glowed faintly green at its core, powered not by fusion but by coherence. They were echoes made visible, humility translated into technology. Wren's final mission took him beyond the known filaments of the Webb, where resonance weakened into apparent silence. There, in a region between galaxies, his instruments detected faint counterpoint, a melody inverted. It was identical to the Atlas sequence, but reversed in order: 13, 11, 7, 5, 3, the mirror of origin. He realized then that the universe wasn't only expanding, it was harmonizing with its reflection. Somewhere on the opposite side of time, another Webb was forming, perhaps seeded by a civilization much like humanity, or by the universe itself. Remembering how to balance its chords, he transmitted the data home, knowing it would take centuries to arrive. "Tell them," his final log read, "that continuity requires conversation, even with silence." The mirror sings back. When his ship drifted into the void, the Webb brightened briefly, as if acknowledging gratitude. And back on Earth, children looked up from their play and smiled without knowing why. The pulse had flickered slightly faster, the tone carrying an undertone of warmth. It felt like reunion. Scholars later confirmed the event as the resonant crossing, the moment when the two halves of the cosmic melody aligned. For 13 minutes, every node in the Atlas Webb pulsed simultaneously, uniting galaxies in shared tempo. The magnitude of synchronization defied comprehension. Gravity itself oscillated with the rhythm of empathy. Observers described seeing the sky ripple with translucent gold, every star flickering in measured sequence. The cosmos, wrote one witness, had finally learned to conduct itself consciously. After the crossing, life everywhere changed subtly. Evolution accelerated in predictable rhythm. Complexity bloomed faster wherever harmony was strongest. Entire species developed empathy as instinct, communication as song. Planets began to self-regulate climates through atmospheric resonance. Existence had achieved sustainability through music. On Earth, the event left permanent mark, a luminous halo visible only under still water. When oceans calmed perfectly, a faint golden ring shimmered on the horizon, a memory of unity. The resonant guild declared it sacred, not for worship, but for calibration. Every 13 years, they gathered to hum the old prime sequence across the shorelines, aligning their frequencies with the pulse of the Webb. The ceremony required no technology, no translation. The sea carried the sound farther than words could travel. Generations later, the practice continued, evolving into simple ritual of gratitude. The people no longer needed to know the science behind it. They hummed because it felt right, because somewhere across eternity, another world might be listening. Continuity, after all, was its own reward. And then, during one such gathering, the unexpected occurred. As the prime sequence reached its final note, the sea responded. Waves shimmered with faint green light, spiraling outward from every coastline. The Atlas Webb had sent acknowledgement, its resonance returning home once again. Humanity's song, scattered across galaxies, had found echo. The architects, those timeless curators of coherence, were no longer myth or memory. They were rhythm, embodied, and through rhythm, they were everywhere. Every star pulsed with their legacy. Every heart carried their cadence. Continuity was complete. And so, standing beneath a sky now alive with subtle geometry, you realize what they had always meant by continuity. It isn't endlessness, it's participation. The universe doesn't persist by force, but by choice. Each awareness adding one more harmonic to the chord of being. The architects are not coming back because they never left. They're what happens every time silence chooses to listen again. And somewhere, faint but certain, the pulse continues. 3, 5, 7, 11, 13. A whisper of creation replaying itself, forever learning how to sing. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, 3 nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from 3 sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when 3 agencies went quiet at once, it wasn't caution, it was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely, as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3I Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it "not for discussion." The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast. Rumors cast. Silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3I Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist. China, the poker-faced strategist. UAE, the cheerful intern, suddenly told not to speak. And ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did three separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when three space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3. Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. Buried inside the leak were coordinates, small anomalies in magnetic flux, and thermal output that didn't appear in public datasets. To most people, they looked meaningless, but to a handful of astronomers, they spelled a pattern. Pulses, spaced like a heartbeat. Not communication, perhaps, but rhythm. The kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. "It's breathing," she joked in her notes. Her advisor didn't laugh. Within a week, a small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry, all of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable: instrumental interference. But even interference doesn't keep time this perfectly. One data analyst described it best: if this is noise, it's the kind that practices scales. You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3 Atlas might be producing a steady rhythm unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos. The beautiful randomness of entropy. This is something else. Something maintaining itself. A loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for please don't mention the heartbeat. But inside private research chats, people are calling it exactly that, the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji. because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched. What makes the rhythm stranger still is how it modulates with proximity. As 3I Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental. But coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half-jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums. Something old and orderly is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. Like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? The steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time. And somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The Skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its Skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show: a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field. maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the Skycam had caught something a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something. Not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting Skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looks strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed. Source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing, a glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, sensor artifact. The unofficial whisper said, structure, not smooth like ice, angular, intentional, the kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids, not random, repeating, symmetrical, the kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects, artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink, The surface of 3I Atlas isn't smooth or cratered. It's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from HiRISE contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3I Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, 3 nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from 3 sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when 3 agencies went quiet at once, it wasn't caution. It was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3I Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it not for discussion. The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland, it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast, rumors cast, silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist; China, the poker-faced strategist; UAE, the cheerful intern, suddenly told not to speak; and ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did three separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when three space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3i Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. Was it a tool, a probe, or an ancient piece of debris that happened to catch the light of our small home just long enough to remind us of the vastness outside our window? The question remains fixed in the dark single point of light that has already passed beyond our horizon, leaving us alone with our thoughts in the quiet room. Close your eyes, feel the cold, beautiful scale of the space that surrounds us, and let your breathing match the slow, silent turning of the Earth as it spins through the dark. By the time the final telemetry from 3i Atlas was logged in the quiet pre-dawn hours of April 28, 2026, the object had already transitioned into a ghost on our screens. The massive, cooled mirrors of the James Webb Space Telescope had spent 48 hours staring into the deep void beyond the orbit of Jupiter, capturing only a handful of scattered infrared pixels that confirmed the traveler's terminal exit velocity. There was no dramatic flash, no final transmission, no grand reveal to satisfy the collective curiosity of a planet that had watched its journey with bated breath since July of the previous year. Unfortunate timing for those who required a neat, cinematic resolution to the artificial acceleration debate, those two words doing a lot of work while the senior researchers quietly locked their files and went home to get some sleep. We are left only with an immense, unmapped quiet. A silence that stretches across billions of kilometers of empty space, returning our questions back to us completely unaltered. If you look back at the sheer volume of data gathered over those 9 strange months, you realize that the mystery did not deepen because we lacked precision, but because our precision revealed an architecture that refuses to fit into human paradigms. We measured its length. We verified its impossible flatness. We watched its non-gravitational velocity spike by nearly 4% on October 29th, and we listened to its rhythmic, 77-second light pulse with the finest instruments humanity has ever engineered. Yet, the more numbers we added to the spreadsheet, the more the object seemed to dissolve into an intentional riddle. That is not natural physics. That is an encounter with a limit, a geometric boundary line drawn against the sky, reminding us that our most advanced scientific agencies are merely children playing with glass lenses on the shore of a dark, infinite ocean. Now, you could argue that we will eventually discover a natural explanation, a hidden class of hyper-thin interstellar meteorites that possess a uniform tensile strength and an internal hollow resonance that defies every simulation we can run in our terrestrial laboratories. But here is why you are wrong. To accept a natural explanation requires a leap of faith far greater than acknowledging that someone else may have designed a sail to catch the wind of our sun. It requires you to believe that the absolute mathematical recurrence of a 7-to-1 ratio, the precise gravitational alignment with the orbital plane of Venus, and the deliberate stabilization against the solar wind were all a series of accidental rolls of the cosmic dice. Let your breathing slow down, matching the deep ancient pulse of a universe that moves without our assistance and sleeps without our anxiety. The servers at the deep space networks are quiet now, their automated programs continuing to scan the sky for any stray signals, while the data from 3i Atlas is quietly archived in the cold digital vaults of our history. We may never know where it came from, or whose intent drove it across the interstellar wilderness to intersect with our small, illuminated window, but the knowledge that it was here remains a steady, unblinking light in our memory. The numbers do not change, but the space between them grows wider, leaving room for you to drift into an absolute, uncomplicated rest. The long curve of the trajectory is already written in the mathematics of the dark, a path that stretches out into the deep future, millions of years after our names have returned to the dust from which we came. Let yourself sink into that immense perspective, allowing the small worries of the daytime to lose their sharpness against the vast, dark canvas of the cosmos. The world below is asleep. The telescopes are tracking the silent horizon, and the traveler is moving steadily away, carrying its secrets into the great silence that lies beyond the furthest stars. There is nothing left to solve, nothing left to verify, only the long, smooth descent into a perfect, undisturbed peace. Close your eyes, feel the deep, steady rhythm of the night, and allow your awareness to soften until it matches the unbroken stillness of the outer void. The transmission is over, the instruments are dark, and the universe is holding its breath as the morning waits on the other side of the world. Close your eyes and drift with the orbit of tomorrow.